Hello, welcome to Tech. I have been off for a while, but I'm back and we are going to do really good things. So basically, today we are just dealing with something simple just to get me started back up. We are looking at LDR and a transistor as a switch. So an LDR is a light dependent resistor, which means it's a resistor, but it depends on light, or its resistance rather increases or reduces depending on the light intensity. Okay, and the transistor can act as a switch, which is how we're using it today. It can also act as an amplification tool. Okay, so today we are just working on a transistor as a switch, and we are controlling LEDs with an LDR. So an LDR, let me show you how it looks like. This is the LDR. Its theory is that when light increases, the resistance, its resistance that is, reduces, and when light reduces, resistance increases. Okay, and therefore if we're using it in this connection of LEDs with a resistor, look at how we explained how you do this, connecting LEDs in series in a previous tutorial, which I will just leave a link to it. Then I just add, I have placed long leg resistor, short leg LDR. Okay, then we connect it to a power source just to demonstrate this concept I have just mentioned. Okay, so when I close this, it dims, it brightens, dims, brightens. Okay, this behavior is now the normal behavior of the light dependent resistor. Okay, but for our case, we want, when there is no light in the room, the LEDs to be on. When there is light in the room, the LEDs to be off. Okay, now to achieve this, we need a transistor. So we'll be using our transistor as a switch. Since I want the behavior to be such that when there is no light, that's when the LEDs light up. I will introduce a resistor and place it in series with our LDR. So they'll be in this case. This is just an example. We have two. Let's say this is 9 volts, and we have R1 and R2. Okay, when resistors are connected in series, voltage is different for each component or each resistor. Okay, and the current is the same. I've mentioned this in a previous video. I'll just leave a link to it. Now, the voltage here and the voltage here will be different. Okay, that's the voltage flowing through this and the voltage flowing through this second resistor. This voltage will be in proportion or directly proportion to the resistor. So that means if resistor 1 is greater than resistor 2, then resistor 1 will have more voltage going across it compared to that going through resistor 2, and so that's voltage division for short. Okay, therefore we are playing with the voltage here. This will be our V out. Okay, so we will be playing with this voltage. When the resistance is high, then the voltage is also high. Okay, which is the opposite of what was happening before. Therefore, when the voltage is high, then the LED lights brighter. This is the opposite of what we were having previously. Okay, whereby when the resistance was high, the voltage was low. Okay, and the LED brightness reduce. I know I have really messed this page up, but basically what I'm saying is that we're playing with this voltage here. Okay, it will be like a range. So depending on where you are, the LED will be brighter or darker. So we'll be using BC547, which is an NPN transistor. I don't know if, yeah, BC547 NPN transistor. NPN not pointing in. In NPN, okay? Let me even put it that way. So we have that, and so since we've said not pointing in, emitter, collector, base, not pointing in. PNP would be pointing inwards. Okay, so in our case, when we face it this way, okay, let me just do this. This is the side that has been written on, BC547. When we place it this way, this is the, according to my sheet, this is the collector, base, emitter. Okay, you have to check the specifications for the transistor you're using because they're different. For my case it's this, but for other transistors it will be different. So the base is connected to a source. Okay, in our case it's the point where the two, okay, we mentioned this earlier. So this point is connected to the base that acts as our source. Since we mentioned here we have a voltage, right? So this voltage is what comes in here and controls the current flowing through the collector and emitter, collector through to the emitter. Okay, whenever a voltage is applied, it's like a short circuit is created here, and therefore current flows from the collector to the emitter. Okay, the collector is connected to the input, and so in our case to the LED, and the emitter is grounded. So I guess we are ready to now tackle the question. Okay, so this acts as a switch. In what way? The base, right? When the base is supplied with a voltage, then the current flows and the LEDs light up. Okay, when the base has no voltage, then there is no current flowing through this collector emitter, and therefore the LED is off. So basically that is what we are doing today. Now remember, this control is done with two resistors. One is a normal 1K resistor and the other is an LDR. Okay, so when you close, then you see the effects. So first I'll leave us breadboard circuit. So there it is. Sorry, I've connected them in series, then I connect them to a source. So the LDR goes to the negative rail, the resistor goes to the positive rail, and then the base is the middle one. Let me just move this a little bit further. because they're too close and the transistor is like a small thingy. So I've not made any changes, I've just moved those a bit. The base is connected to where the two meet. Then the collector is connected to the LED, the short leg of the LED. The collector is connected to the short leg of the LED. Let me use this orange wire. Short leg of the LED. And the emitter is grounded. The emitter is grounded. Ground connect to the negative rail. And then the resistor is connected to the negative rail too. Okay? The resistor, no, not to the positive rail. So by now you have two on each rail. One leg of the LDR connected to the negative rail and the emitter connected to the negative rail. The long leg of the LED, which is connected to the resistor, is connected to the positive rail, and the other leg of the resistor in our voltage divider circuit there is connected to positive rail. Okay, then we have the positive rail, connect that, and the negative rail, connect that. Okay, and then we have our source here. Oh, I have just noticed the problem. So this was actually a challenge for me when I was working on this. So when this happens, okay, when it lights up without dimming, then we need to increase the resistance until we need to increase this resistance. So let me just, this was 1000 ohms, so let me just use the one I got worked well, 20k. Okay, so you'll just work on increasing the resistance when this happens. First you try interchanging the collector, emitter, okay, reverse it. If it doesn't work, increase resistance. Okay, so for me, let me just do that real quick.